Welcome to the GridWise Architecture Council's video library. The following presentation by Dr. Najib Dandachi, entitled The Evolution and Disruption of the Power Sector, was presented to the GridWise Architecture Council on December 3rd, 2025. Welcome, Najib.
Good morning, everyone. Thank you for the invitation. I am honored and delighted to join this meeting and with the opportunity to share some of the thoughts and ideas. I hope that you can hear me well.
We can.
Very good. Okay, let me try to put my shared slides on the screen. You can see my screen?
Yes, we can.
Yes. Okay. I have around 45 minutes, I believe, to go through some of the material that I have prepared specifically for this talk. Allow me, first of all, to introduce myself. I am a power system engineer. I have BSc and MSc and PhD in electrical engineering from Imperial College in London. I started my career in the electricity supply industry in the UK just before the privatization, after finishing my PhD. And 15 years later, I was taken to Abu Dhabi to support the unbundling of the electricity and water department and sector in the UAE, modeled on the UK, basically, regulatory model and regime, trying to mimic the same setup in order to introduce greater efficiency and effectiveness, I think I can say, into the water and electricity sector. And it's kind of like unique here in the Gulf region. I'll elaborate further during the talk why I think it's kind of like unique. When I first joined, I was in charge of the National Control Center. I came to run the project of the National Control and manage the National Control Center. So I did that for a few years. And after that, I was appointed in charge of the operation and maintenance of electricity and water, control of electricity and water, and the telecom, the fiber optic network that served the business. A few years later, I was assigned the asset management director in the business to introduce ISO 55001 and PAS 65 at that time. So you can see that my background is heavily system operation control and then converted, if you like, into strategy and engineering management. Since 2016, I established Al Usul, which is the logo that you can see on the top right-hand side of the slide, which stands, this is Arabic, and it stands for assets, basically, because of the believe that electricity and water and utility assets are valuable. Hence, it's in gold color, the Venus flower, if you like, which is focused on care, attention, love, as we do towards our assets. And I heard the conversation earlier, we're talking about assets, and I was delighted to hear that. So I'm very much focused on management of assets, especially in the new power and water sector, to deliver value for the organizations. This is quickly my background. I would like to start first. Feel free to interrupt me if you like, no worries whatsoever during the presentation. I'm quite happy with that. If there are some burning questions or issues to be raised and discussed, no worries. I would like to start first by, speaking about the big picture, especially, I know we're talking about power and energy in general, and it's almost impossible to separate the sector from the rest of, our social activities, the politics, economy, environment, and everything. So I will start by talking about the big picture, first of all, before diving into more technical side of the presentation and sharing with you my thought, looking through the crystal ball that I have here at home. I'm not going to show you the crystal ball, but I will talk to you about what I see through my crystal ball. First of all, let me, start by a trip down memory lane. Really, I do believe that the power sector in the world, the global power sector, went through a number of major disruptions and milestones, if you like, throughout its history. First was really the war of the currents. I'm sure most of us are familiar with the war of the currents between our founders, the Nikola Tesla and Thomas Edison, between the AC and the DC, and the fight and the support from General Electric, Westinghouse, and what have you, and the businesses. And ultimately, of course, AC won the war at that time. Why is that relevant? It's very relevant, and we will see why it is important to understand the relevance of the war of the currents and where we are nowadays with everything that is happening around us. After the war of the currents between Tesla and Edison, of course, came the steam and the steel age. Big is beautiful, large power stations, coal-fired power stations, of course. Sorry, questions, anything? No? Okay, because I heard something. Right, the steam and the steel age, large power stations, large steam turbines, long distance transmission and distribution, centralized planning, and what have you. After that, of course, the nuclear era, when the nuclear power plants started to dominate the scene everywhere, different technologies, and it's continuing nowadays, the nuclear deployment. Although some countries after the 70s, wanted to shift the focus from nuclear to more green, but the nuclear at that time, and the French, of course, were the largest deployer of the nuclear power generation. And I believe right now they are in the range of like 70 plus 75 maybe % of their power production is coming from nuclear, while other countries gradually shifted for various reasons. Then the fourth, in my opinion, big disruption and big bang was Margaret Thatcher privatization in the early 90s, late 80s, early 90s, when most of the utilities were privatized, British Telecom, the Central Electricity Generating Board, CEGB, the British Gas, and what have you. Part of it because of political reasons, part of it because of economical reasons, but eventually that swept the whole world. What does it mean? It meant that the engineers, and I'm one of them, were no longer the sole authority and the people in charge of the power sector. The economist came along and joined the engineer in shaping and maybe disrupting, the engineering side of the power sector. Year 2000, 2010 started the renewable in angle, and we'll see some curves later on during the presentation where we can see how the renewable disruption changed the shape of the power sector across the world, starting with, the developed countries, naturally. But what that meant also that in addition to the engineers and the economists, now the environmentalist has joined the team. And some of us now, we hear and read in the literature the 3 E's, the engineers, the economists, and the environmentalists, who are now really driving the sector, disrupting the sector, managing the sector, setting the direction. 2016 onwards, and why 2016? We'll see that in a minute. The greater transition, because then really renewable energy took over, most of the countries, and took over even the fossil fuel. First time in 2016, the global energy, plus the digitization, the digital disruption, and we are still living in this period of time, the great transition and the digital disruption. This is the curve that can show us that globally, although renewable energy started to take, a good shape from year 2000, but in reality, 2016 was the year when renewables surpassed fossil fuels. Now, the question is why we see this 2000 and 2010. The first COP was held in Germany, I think, in 1995. Kyoto was signed in 1997. So countries started to look into this accord and the direction and the need to, control climate change and carbon emission. This is why we see, in reality, from year 2000 onwards, everything is taking different shape and form. And while this is globally, I will show during the rest of the presentation, some countries, how this meant for some countries. You will see that there are some similarities in some countries where different countries have different shape, although they are still embarking on the renewable deployment. Now, I mentioned the 3Ds, the 3Es. Now, also we see in the literature, we see people talking about, the new world regime. The new world order is governed really by this equation. I don't have any equations in my slides. Apart from this one, it's the 3Ds and the 3Es, the digitization, decarbonization, and decentralization. With the 3Es, the engineers, economists, and environmentalists. Those 3Ds and 3Es are really deciding the shape and the direction of what we are seeing in the power sector, and to some extent in the water sector as well, especially in this part of the world where water and power are coupled together in the production through the desalination process, and are being decoupled also, because of the decarbonization and because of the decentralization. But here, the production of power is combined cycle cogen, where the water is effectively in the summer a byproduct, almost free product, because of the power consumption. So we have enough steams to take it to desalination and produce water, because obviously there are no rivers here and it doesn't rain much. So the water desalination is key for the society here. So this is the only equation that we have. The 3D and 3E are shaping the future of the power sector. But what does it mean in reality? Okay, people talk about it, politicians, economists, investors, they talk about the 3Ds and the 3Es, they talk about reducing carbon emission, they talk about efficiency, effectiveness of the market and trading, but in reality, I'm pretty sure that most of us are familiar with the duck curve. We see this is the shape of the demand that the system demand that system operators, and I come from system operator background, are having to deal with gradually from 2018 to 2024. This is the California, of course, famous duck curve, which is also now changing in the shape rapidly because of what is happening. Started with the solar rooftops, obviously losing the demand from the grid during the daytime and getting back on the grid during the nighttime. But we see that data centers and BESS are helping indirectly to recover, the canyon, the shape, the valley in the duck curve. Why this is a problem? All those who work in system operation appreciate that it's not really, in a way, the magnitude, the change of the system loaded drop, but it's the time that the operator in the control room will have to deal with in absence of any other means to dispatch, renewable, having to deal with thousands of megawatt on daily basis, cycling with problems with cycling, of course, in power plants that you can't continue to, reduce the load, deload, or shut down and start up on daily basis within this time. But operators, they were forced because of the environmentalists and to some extent the economists having to deal with these phenomena, and the prime role of those operators became like, balancing orchestrators, trying to make sure that, the grid is maintaining reliability, security within the agreed security standards under regulatory regime or without even a regulatory regime, respecting security standards and making sure that sometimes even the prices are within the affordability if possible. We see this in duck curve, and people talk about intermittency and variability, that the grid operator are obliged to cope with the intermittency and the variability of the renewable energy. Sometimes, in my opinion, maybe mixing the two or confusing the terminology and the definitions of the intermittency and variability. So I'm trying to show here, in my opinion, that from a system operator point of view, the intermittency is not a big problem as far as system operator is concerned. Why? Because to a large extent, this is predictable. And there is plenty of time for the system operator to respond to. Maybe from planning point of view, this needs to be taken into consideration to make sure that the system operator is equipped and is provided with the appropriate resources, maintenance also, to ensure that the intermittency is managed because it's predictable. The problem is mainly with the variability. And here what I'm showing is an extreme scenario of one power plant that we have, a PV power plant that we have here in the region, the GCC. And this is an extreme scenario of the solar eclipse, where you can see that around 450 megawatt dropped within almost, half an hour because of the solar eclipse. And then between 8:30 and 11, it recovered to its full declared capability. So the variability is the problem for the system operator, having to forecast the generation rather than the demand, forecast the generation and try to cater and prepare the system, the grid, to make sure that it rides the variability at that time without compromising the security of the grid, without compromising the supply and interruption to the customers, especially if we're talking about summertime when the temperature reaches 50 degrees during the middle of the day, and the majority of the load is AC, and people really would suffer enormously without power supplied even for a short period of time. But what are the mitigation measures? There are mitigation measures, obviously, for this intermittency and variability that people talk about as far as the renewable energy is concerned, including the technology diversity, if possible, the geographical location, making sure that from planning perspective, the location of these plants are not very close to each other, to such that the cloud or weather effect are not, impacting all the renewable fleet. So try to diversify. We talk about the AI tool to forecast variation and dispatch, and this is becoming very critical. Some countries in this part of the world have announced extremely aggressive renewable energy plans and national targets, sometimes beyond the capability of the grid to take it. Yet, this is direction from leadership. So it's important to support the planners and operators with the right tools and facilities and systems to make sure that they are optimizing the opportunity to deploy as much renewable as possible. Although we are, of course, an oil and gas region, but the region is shifting very, very rapidly away from the oil and gas, mainly gas generation, the majority of the power plants here, and shifting away into solar. The energy storage, of course, Saudi Arabia, UAE, Oman are installing among the largest BESS projects. So it's not only, in the size and the magnitude, but also in the speed, the pace of deployment of renewable energy and battery storage is enormous. Interconnecting with adjacent network, of course, the GCC here is very much interconnected. All the member states of the GCC are interconnected and now actively in the process of connecting Iraq, discussion about connection with India, between the GCC and Egypt, and even across the Mediterranean to Greece and Europe. I will show a slide on that just to give it some more visuality. Demand response also is an opportunity, the last measure to help the integration of renewable through demand side management and contracting with large suppliers to disconnect for a fee in case of emergencies. But the major concern is really the variability rather than the intermittency because of the installed capacity. And probably this is the story in most countries, not just in this part of the world. Again, on the reality impact, like I said, there is in certain places disjointed coordination or lack of coordination, if you like, between the vision, between the targets and the reality and the feasibility. I was advising one of the countries here in the GCC, and I advised that the declared national targets cannot be evacuated by the existing grid in terms of the quantity and in terms of the time that these national targets are announced. And maybe in some instances, it was, in my opinion, no more than 30% of the announced target that could be met and achieved by the national grid within that specific country. Having said that, there is also some particularity of this region that the majority of the countries in the GCC, they have excess power, while majority of the countries around the GCC, they have deficiencies. So that is an opportunity through the interconnection. The demand and versus generation forecasting, we're used to forecasting the demand, which is related to customer behavior, but nowadays we are having to deal with, the demand, the generation, forecast the generation rather than forecasting the demand, or in addition to forecasting the demand, which for the load flow analysis and the power system analyst, it meant that the net Newton-Raphson and Gauss-Seidel load flow solution, the state and control variables are, swapping each other, replacing each other. The generation is no longer a control in a way. It's more a state variable or a constraint in addition to sometimes being a control variable. So that changed also the goalposts as far as the power system engineer is concerned. The inertia, it's the new spinning reserve. Because of lack of inertia from the renewable energy, non-rotating production facilities. Most, in my experience, that I'm dealing with many countries with their transmission businesses and distribution businesses, advising in various capacities, most of them are not aware of the existing inertia on their system. They are kind of like flying blind. And I'm quoting a system operation director from UK, to be honest, following the blackout that happened, I think, August 2019 on Friday. They lost part of the country in the afternoon at the peak hour, and the system director declared in open meeting that we've been flying blind, that we are not aware of what exact inertia we have, while right now some regulators in many parts of the world started to impose regulatory requirement on transmission businesses to have their inertia declared and minimum level of inertia held on the system on daily basis and reporting to regulator about this. Now there is a new technology now that is being deployed where inertia is being measured as well, not just simulated or calculated, because obviously lack of proper analysis of assessment of the inertia could lead to curtailment of renewable energy and suboptimal operation of the transmission network and dispatching, of course. In addition to that reality, I think I'm fine with the time, we're experiencing supply chain challenges. Reality means that more and more interconnection between countries are being pursued and deployed for this mutual support. Most of the time, this interconnection is preferred to be HVDC, and the suppliers of the HVDC, the three main suppliers in the West are basically Hitachi ABB, General Electric, and Siemens. They are fully booked, to the extent that if you speak about a project, there is nothing that can be done maybe from now beyond 2031 and so on. So the supply chain challenges mean that it's not always possible to pursue and install these interconnections as desired or as preferred by those countries. The Spain blackout, I want to mention that it was in the latest report that was issued by the utilities and the regulators. It's still not clear 100% what has happened, but although people are pointing finger at inertia and oscillation between Spain, Portugal on one side and France and the rest of Europe, but it costed the system few billions in the blackout. And while we are continuing to talk about artificial intelligence and smart grid, and up to now, we are not 100% clear about what happened in Spain. And this could repeat itself anywhere else in the world, anytime. And we are not really putting sufficient efforts into the R&D, into the smartening of the transmission network, or even distribution network for that matter. And we're assuming that if we have smart meters deployed everywhere, then we're kind of like, yes, we're getting close to smart grid, and far from it. In my opinion, that does not exist. Honestly, there are some pockets of smart networks, but smart grid to the extent that is required to support the renewable energy deployment and relieving the operator from the pressure that we have, some of it that we have seen already, it's not existent. It is not there. I mentioned the curve before. This is the curve for the US, the curve for the European Union, and China and India. You can see that while there are similarities between the curves, especially between the US and the European Union, China and India, who are really the drivers of a lot of the energy issues in the world nowadays, and energy in the capital E, not in the electricity sense. The shape is a little bit different. While they are still following the trend to deploy the renewable energy, but the fossil fuel and the carbon emission remain on the high side compared to Europe and the United States. So I didn't want to show the rest of the world, but we can see that the big four, if you like, here, you can see the contrast between what's happening in the US and Europe and what's happening in China and India. And maybe there are some political variables, political factors, economic, social, what have you, but we can see the contrast between those four curves. Like I said, we talk about smart grid everywhere, and we know what it should look like, but in reality, that is not happening in an integrated and coordinated manner. There are some pockets and maybe in silos, some smartening of the activities is happening, especially with now more deployment of the EV, and the transportation sector is being electrified in a faster way, to the extent that I think most of the oil giants realize that their main customer, the transportation sector, is kind of like escaping and running away from them into the electricity. So most of them are, instead of beating the customer, if you like, joining the customer. If you can't beat them, join them. They're buying into electricity networks to follow the customer from strategic point of view into the electricity sector. So if the transportation sector is moving gradually away from the oil and gas, they're chasing the customer into the electricity sector. Now, looking through the crystal ball, I'm trying to see if this can be separated into the right side and the left side from the grid perspective. On the left-hand side, the grid is becoming more critical, more requirement for the grid because of greater interconnection and the war of the currents. In the war of the currents, AC won the war, but now gradually we can see that DC is gaining ground after 150 years. So Thomas Edison is, getting his revenge on Nikola Tesla, and we see more and more DC even within the same countries. Some countries are now reinforcing their grids through DC between the four corners, if you like. We see hydrogen also supporting, the demand and supporting more centralized, more grid connection. We see the nuclear SMR. Rolls-Royce is leading now, and I think they have already started the preparation and design for the first type of SMR in North or South Wales. I think it's in the UK, in Wales. But this is one of the aspects of the future. Nuclear SMR, modular, maybe 100 megawatt, 200 megawatt, rather than the big, large 1 point something gigawatt. And we here in the UAE, we have one of the largest in the world. In Baraka, 4 reactors, 1,400 megawatt each, Westinghouse technology deployed by the Korean. But the nuclear SMR is a game changer in the maybe next decade or so, and it will reinforce the role of the grid. The grid of the future, of course, require greater smartening, more artificial intelligence, and more so closed loop control, which is something I was, listening to and expecting to see even when I was doing my own PhD at Imperial College. That's like, I'm not going to say how many years ago that was, but enforcing the grid is a tension against self-satisfied rooftop. So with the current PV cells efficiency in the 25%, let's imagine this solar cell efficiency increase to like 40 plus. And the batteries also, the BESS efficiency size, like the mobile phone, also reduce in size and higher efficiency. Can household owners have their own solar system, their own, rooftop supply without the need for the grid interconnection apart from emergencies, for example? Can the blockchain and peer-to-peer energy trading compensate those households if they don't have enough energy, to the extent that the grid flow and supply will be reduced to the minimum only for industrial or maybe only for occasion, but the majority? So effectively, the duck curve will take the whole day, and it will be almost flat out from at least residential and domestic supply. Is that something that we expect to see in a few years if the PVs become more efficient and the batteries, like the mobile phone, the size of the battery is reduced and became more efficient? What about the wireless transmission? So we can see that there are some technology advances, expectation that will reduce dependency on the grid, while others, of course, require a grid support and a grid smartening and artificial intelligence. I mean, this is the swing between the two sides, if you like, that you probably can see the future, and only time will tell which way we will lean more on. I did mention the interconnection. I mean, this is some of the examples. One of the exceptional interconnection is the south of Morocco to the UK, the X-Link, few thousand miles subsea cable that I think the UK government now decided to withdraw the support, but that was an idea for connecting the rich south of Morocco mainly in wind, actually more so than the solar. The speed of the wind is almost continuous, around like 50 meters per second, which is unbelievable, all the way up to the UK and Italy, Albania, Greece to Saudi Arabia. Not only Egypt, Greece to Saudi Arabia. You can imagine on the map. Azerbaijan, Uzbekistan through the Black Sea, Georgia, Romania to Hungary, to provide Europe with additional power from, the ex-CIS countries instead of the Russian gas, maybe. Australia, Singapore, Australia, Indonesia, Australia, Malaysia. So we're talking about huge projects of interconnection. I mean, this is just an example. And who knows, maybe UK to the US sometime, or UK to Canada. But certainly interconnection is a theme for the future to consider. Speaking of the UK, and this is the result of the market behavior, the UK, with this interconnection, import from France and export to Belgium, Holland, Denmark, and Norway. They're importing 2 gigawatt and exporting around 3 plus 4 gigawatt. So does that, make engineering sense? Why this power does not go directly from France via Europe all the way up this interconnected. But it's all market driven. And it's all about balancing. It's all about, positioning yourself from a market perspective. And this is where also we can see the 3E and the 3Ds, working together to establishing the new equilibrium in the power sector. It's very important. I'm trying to wrap up now. It's very important to understand that the organizations of the old 90s before the privatizations are no longer there. So we need to adapt in every way, every shape and form. Otherwise, the business will collapse. And this is what I call the organizational Darwinism, if you like. The evolution is the strongest of the species that will survive. And this applies to the power sector and the businesses where the engineers are no longer engineers, but they have to do everything. And the business need to adopt smart tools, applications, software, anything possible to ensure that the prime objective, the raison d'etre, if you like, of those utilities, which is providing, initially was a service and now it's a commodity, the electricity and supply to customers in reliable, secure, affordable manner, continue to be, secure. We speak about the digital asset management, referring to what we said at the beginning. And this is something maybe I want to also touch on. And by digital, I think we mean the smart, but there is perhaps some confusion about smart or digital. I mean, this is a mobile phone. And sometimes we call it digital phone or a smartphone. And I struggle to understand why we call it smartphone. That's a digital phone. We have digital networks now, digital grids. They're not smart. We have smart TV. You're probably seeing me now on the screen. It's a smart screen. Why is it smart? It's a digital screen. If it's not doing any collection of data analysis and then either helping me with a decision or taking the decision on my behalf in a closed loop manner, it's not smart. So I think we need to redefine, widely what we mean by smart. My phone, if I'm not using Siri or it's not helping me with my schedule and meeting and doing things, it's a digital phone. It's connecting to the internet, providing me with data, with information. But is it smart if it's not doing anything? So the digital asset management need to be smart in the sense that it should support the operator, planner, economist, environmentalist in collecting information, venting, cleaning, cleansing, analyzing, and then supporting, if not taking decision in closed loop, like automatic switching to self-heal a network after a fault in a reliable and secure and safe manner. So the i4 generation should be about smartening rather than digitizing our network that we talk about. I think that's my last slide, and I have a couple of minutes to wrap it up on time. Decarbonization is the key driver. I know I spoke about the 3Ds, and we say these are the drivers of the power sector, but in reality, it's the decarbonization. The digitization and decentralization is a consequence rather than a cause. It's how we are looking to mitigate and shape the sector because of the decarbonization. So it's really the key driver in my opinion. The digitization is the mean to manage, and decentralization, and sometimes we talk about democratization, also the 4D. It's a mean to manage to help and give the sector more tools, resources to handle itself. A transition state, we are now in a transition state. How long it will take, I don't know, but for sure, each era bring its own challenge and introduce a new one. And there is no one business or country or even a group of countries can do this on its own in the transition. we do require cooperation and support and mutual support between all those players, while so far we see there is no transition without transmission, because that transmission will allow, the mutual support, and will allow renewable energy to travel far and provide perhaps more reliability to the grid. The thinkers here, like your good selves, and thank you for this invitation, they have great role to play. The think tank strategies, innovation, and R&D, because from my experience, those who are consumed on daily basis in the utilities, they really have no time to think. They act, most of them, on the in-tray. They receive requests and they respond to it. So it's more reactive rather than proactive. Plus, after the privatization, all the research centers and, training centers were like removed from the business because it doesn't pay, it's not bankable. It's different type of business. It's not the core of the business. So there is a great opportunity here for the thinkers, those who can sit back, who can see, observe, and come up with proper thoughts, ideas, models, tools, applications, with the right fund and support, of course. And this would be much cheaper than having to deal with the crisis in firefighting mode, as we have seen, for example, in Spain after the blackout. The cost of the blackout was like 9 billion. If we had invested maybe, and I'm not criticizing the Spanish, honestly, I know they have done everything they can to manage the situation and continue to do so. But if we collectively spend a little bit, maybe 10% of this cost of the blackout on tools, applications, on cooperation, on coming up with the smart facilities and resources, we probably could save billions. And for this reason, I'm calling for kind of like a global alliances, because this is a global problem. It's not a problem of, utilities in Europe or in the Gulf or in China. It's a global problem, and we all gonna be facing similar difficulties, similar challenges. So we need to cooperate on the way forward and on smart solutions. I would like to thank you for the opportunity. I hope that I've managed to finish and wrap up on time. And I'm glad that I am speaking the language that we all understand. And I hope that this was useful. Thank you for the opportunity. This is part of, a series of power system talks and lectures that I am doing, and wanted to share this with your good selves. So thank you for the opportunity.
Thanks, Najib, for that insightful presentation. For more information about the GridWise Architecture Council, please see our website at gridwiseac.org. And don't forget to subscribe to our YouTube channel at the site listed. Thank you.